MODO includes a comprehensive, fully integrated node-based rigging system that can be accessed via the schematic viewport. This is where channels and a large number of modifiers can be brought together and linked, allowing for experimentation and fast debugging. One unique feature of MODO's schematic viewport is the ability to create workspaces. Workspaces are a way of managing complex nodal networks on the fly by grouping specific parts of a network into smaller, easier-to-read collections of nodes. Approximately 100 channel modifiers are available to you via the schematic, including math, conditional, matrix, time and vector, as well as many other modifiers designed for specific tasks. For faster rigging, a number of common rigging constraints can be applied via UI buttons. These allow you to apply position, direction, path and surface constraints quickly based on item selection, and results can be easily viewed in the schematic for additional rigging. The UI also includes a number of tools that aid basic rigging tasks. But you can also undertake many of these tasks by using drop actions. These are specific commands or combinations of commands that are run when one item is dropped on another, and they can help to speed up many repetitive rigging tasks. MODO also utilizes a layered transform system. By adding any number of pre or post transform channels to an item, you're able to build up a number of values for a channel, and the order in which these values are applied can create different results. The use of layered transforms can also often result in much lighter scenes. MODO's setup mode allows edits to be made to a rig in its setup position with deformers turned off. This is useful as it allows you to edit a rig at any time during a project. MODO supports both dual 2D and full body IK, helping you to recreate both mechanical and organic motion. Full body IK allows you to define multiple IK goals in a hierarchy, and also gives you extra control over weight and limits. This allows you to fine-tune how the rig will respond, and IK-FK blending is also fully supported. Chains of items or joints can be quickly created with the skeleton tool. Joints can be created symmetrically and in any defined hierarchy, and with intersection turned on, joints will be placed at the center of the mesh that's clicked on. Binding a mesh to a chain of joints can be done with the bind command. A number of binding methods are available to you, including rigid, smooth and heat. Heat is particularly useful as it stops the bleeding of weight maps into areas where they're not wanted. But ultimately weight maps will need to be adjusted, and by utilizing its painting system, MODO provides you with a range of weight painting tools that allow you to edit and view the weight values associated with any selected points. MODO's whole deformation system is node-based and is an order of operation system, which allows you to easily experiment with deformation results. Much like modifiers, a range of deformers such as transform, morph, MDD, lattice, fall-off and wrap can be quickly applied to objects in the scene. As deformers are added to an object, they form a stack which defines an order in which they will be fired. This order can be easily changed by dragging deformers to different positions in the stack, and groups of deformers can be grouped and normalized as required. Another interesting feature of MODO's rigging system is weight containers. These allow you to store and deform collections of points irrespective of which object they belong to. This allows you to use one deformer to easily deform parts of multiple items. But most powerful of all, it allows you to easily add and remove points that will be influenced by a deformer, even allowing for whole objects to be quickly swapped in and out of a rig. One very important aspect of rigging in MODO is that due to the way it handles vertex data, quite drastic adjustments can be made to geometry with no impact on the integrity of the rig, allowing for a non-linear approach to rigging. And the same is true of morph data. With a set of animated morphs defined, you're able to adjust the base mesh without affecting the integrity of any associated morph maps. Rigging can often involve repetitive tasks. For example, you might want one part of a rig to be used multiple times in a scene. In this situation, you can use assemblies. Assemblies are packets of a rig that you collapse into a single item in the schematic. Specific channels within that packet can then be exposed. Assemblies are a preset type, so can then be saved to disk, and when reloaded through the preset browser, can be linked to other aspects of the scene. MODO's embedded rigging toolset includes many powerful rigging systems that allow you to create scenes that pipe values from modifiers to deformers to shaders and back again. It's a fluid system, and the key to how MODO achieves this is the holistic manner in which MODO treats scene creation.